Okay, so what we're going to do today, I'm kind of, this is one of my favorite topics, is to tie in the application to the database. It's because when you tie in an application to a database, I mean, here we've been coding all semester long, call it 70 days, and we've just been building applications. We haven't really tied in those applications into a database in which data will persist. In other words, in our applications, we can like add a new product, but then you close the application and that new product goes away, right? Or you could delete a product and then you close the application and the product comes back. I mean, the whole advantage of building software is to work with data. It's arguably all about the data. You maybe have heard is, data is the most valuable commodity on earth. It was like 5 years ago or something. They said data is worth more than oil. Right? Oil used to be the most valuable commodity on earth. Now it's data. Okay? Data is ultimately stored in databases through the interface of an application, right? So we're tying it all in together, which makes this very real world, because ultimately, as you go out in the real world, you will be working with databases. I mean, there's no point if you're not working with a database. And so I like this exercise because it's the beginning of making software that's more real world. And obviously this is just the beginning. There's more that we will do to doing that. Now, what we're going to do is we're going to do CRUD operations. You can kind of see create, read, update, and delete, aka CRUD. CRUD is a great academic thing to do because all the operations you can do on a database. And we're going to be doing that, of course, with Visual Studio. What are we in right now? Visual Studio Community 2022, whatever the version is, and with a database. Now, we're going to be doing CRUD on a thing. A thing, call it a noun, whatever the thing may be is not really super important. But any noun, any person, place, or thing can be stored as in a database table. Okay, that thing becomes a table, and that's what we're doing CRUD operations on. The databases the database that we will be using is the database that is already installed when you install Visual Studio Community. You all check the box that said forms development. Like during the installation process, you check the box. Included in that installation came a database software called Express. The version, I think they call it local DB even on your systems, but basically there is a database software, call it a DBMS, a database management system for managing databases. That version, in other words, of SQL Server is Express. There are other versions of SQL Server that you have to pay for. Of course, Express is meant for like academic and like learners. But of course, Microsoft will charge you licensing fees if you want to actually have production applications and databases, right? So Express is great for learners, and so we're using that SQL Express that comes for free. Some new tools that we have not yet learned in this class we'll also be using is called Entity Framework, or EF for short, of course. Entity Framework is the Microsoft package. Well, you can kind of see here, I think what I highlighted says a lot. Entity Framework is an object to database mapper. Object to database mapper. And so, classes. You create classes. We know objects. When you instantiate a class, you have an object. We're going to take those objects and map them to a database through this built-in package. We need to actually install some packages that are called, the Entity Framework, or EF, built into .NET. You just got to install these packages, and then you could take these classes, these objects, and map them to a database. So Entity Framework is specifically a .NET thing, right? It is part of .NET. So if you're in the Microsoft realm of development, that's where you will find Entity Framework. If you're out in the JavaScript world or some other development stack, you're not going to find Entity Framework. It is specific to .NET. Also, we're going to be using this tool called LINQ. LINQ is also a part of the .NET framework. LINQ stands for Language Integrated Query. In other words, it's integrated into C#. What was it integrated to? It's integrated into C#. Okay? And so what you're going to find is that all this SQL that you just got done learning is to query databases. Okay? LINQ is all that functionality of SQL, all those SQL statements. It's literally just another way of working with databases. It's those same select statements, those same update statements, but this is built into Microsoft, and you might go, really, why? I got to learn another one? And you're going to find out it's not a huge learning curve. And there are some benefits of LINQ over SQL. SQL is like 70 years old at this point. And so there are some benefits of LINQ, such as like you get IntelliSense. There's some speed considerations. And so LINQ is language integrated into C#. Queries, we just learned a bunch of different queries using SQL, but it's this is how you are going to query a database. This is how you can query a database in C#. You can still work with SQL. A lot of times you're just putting your SQL in strings, and you find out when you're just putting things in strings, you don't really get IntelliSense. And so from my point of view, one of the biggest advantages is that you get IntelliSense. In other words, with LINQ, you get compile time errors instead of run time errors. You don't have to wait to actually run your software to start getting errors when you're hitting the database. You'll get more compiler time errors when you're using LINQ. Okay, so on one hand, it's like, really, do we have to learn another way of doing this? I get that, but there are some benefits to using LINQ. So this is what we're doing. These are the tools that we're doing it with. Okay, and you had a question?
So it's kind of like how HTML and JSX for React is like basically the same thing, just a little bit different.
Same thing, a little bit different. Same thing, a little bit different. So let's. I'm going to go ahead and start now. I'm creating a Windows Form app, right? So in this class, we do work with Windows Form. It's a data technology, but Entity Framework is not. Okay, Entity Framework is very modern. Entity Framework is currently going through revisions, and modern application development does use Entity Framework. So learning Entity Framework, or at least getting an exposure to it in this class, is development that, again, modern applications utilize. So even though the Windows Forms side of it, a little bit dated, Entity Framework and LINQ, not dated at all. So I'll say EF, and I'll just say EF demo for my solution name, and EF demo, whatever, doesn't matter. Okay.
Broken. It exists.
It already exists. So let's back up. EF demo 2. Okay. So bring this code over here, and this is a place we've all been 100 times. A starting solution that's empty. And so, probably the first thing I want to do is go ahead and install some packages. We haven't done that before. We're going to bring in some what are called dependencies, some things that are not installed by default. And so since we haven't done this before, you're going to find these under the package manager. And so off of the tools menu, package manager, you're going to click on to manage packages for the solution. Again, this is code that you can bring in to your solution if you click on browse. I've kind of typed this before, but these are the two queries that you're going to work with: Entity Framework Tools and Entity Framework.SQL Server. So those drop downs won't be there for you. You will have to type those out. And as you start to type Entity Framework Tools, you can see the Entity Framework Core. There's a keyword core. Core is the latest version of Entity Framework. Think of it as, you know, version 1, 2, 3, 4, and then core. You know, core just means that these apps will run on top of Linux, or they'll run on a Mac environment. They're meant to be cross-platform. So what I'm going to do is I'm going to click on this core, and then I need to check this box to install it into the project. And I'm just going to click on the latest stable and click on install. So we're going to install Entity Framework. That's basically what we're doing here. There's a couple different ways of doing this. I'm going to show you how I do it. I'm installing the tools first, Entity Framework Core Tools. Click install. And I get the little green check mark here. And then under installed, if you kind of clear that out, you can see that the tools are now installed. I'm also going to search for Entity Framework SQL Server. And again, here up at the top, Entity Framework Core SQL Server. And check this box to install here. Okay, and now we're just bringing in these dependencies, and we have what we need. We need those two things. And you can see these are the two packages that I've brought into my solution so that I can work with some Entity Framework code. Okay, so that's kind of step one. Step two is we need to define our class or our thing that we're going to save in a database. I don't really care. What is our thing? I'll take input from my class since you guys are eager to participate. What is our thing that we're saving? Customers. So we're creating a class of customers, right? So we all know how to do that. I'm going to right click and add a class. And I'm going to click on the class, and this is going to be customer.cs. Now, you know me, I like to make this as public class of customer. And there's a lot of, in Entity Framework, coding by convention. You guys are familiar with coding by convention in this class. You might not remember what that means, but basically, by convention, your variables have a certain notation. Pascal, camel notation. Your methods have a certain convention, capitalized letters. And so these are just practices, right? That you know, in this class, we implement these coding conventions. Entity Framework has a lot of conventions. And so one of those is that when you say something like ID, here's my property for my customer ID, Entity Framework, EF, automatically makes this a primary key in the customer table. So just by having the convention that is ID, and it really doesn't matter the caps, it could be like ID like this or ID like that. It's automatically a primary key. which you know the purpose of a primary key is to uniquely identify each row. It is auto-incrementing, meaning it starts at 1, 2, 3, 4, and so on. So when we add a new customer, it'll just auto-increment the customer ID. Now that is a convention. You can overwrite that convention. Okay, that's not important right now. That is kind of a default behavior in Entity Framework. Okay, that when you have a property, by the way, auto-implemented property with an ID, it's automatically the primary key. Let's go ahead and say customer name. Sure, what else? Now, one thing we haven't done a whole lot of is kind of initialize these to a default value. This assignment right here says that for every new customer, if you don't give them a name, by default, it's just going to be an empty string in the database. We could do all sorts of things here, but we'll just give it one more thing. We'll say, what else do our customers have? How about, I don't know, decimal double, I don't know, like in a budget amount of money that they could spend. And we start that off at whatever you want. Double dot max value doesn't really make a whole lot of sense, but maybe just 0. Okay, so our class we're just going to keep kind of simple just to get this up and running. So we're going to have a primary key column. So these properties map through Entity Framework. We're mapping this class to a database. And there's going to be one table. It's going to be a customers. Notice our class is singular. Our table will be plural. It's the customer class. It's a table of customers. Yeah.
And do you have to put the get and set like that, or can you do it the other way that we did?
I've only ever done it this way. So can you do it the other way? Is something I've never experimented with. But that's, I mean, it's a good question, but I just don't know that answer. Worth tinkering with, though.
Okay.
All right. Oh, should I tinker with it right now? Let's not tinker with that right now, because if it, I'd rather this work.
Mm-hmm.
But it is worth tinkering with. Okay, so what have we done so far? Boot up a program, install some dependencies, make a class, everything you haven't done the dependencies before, but you've done the class 100 times. Maybe not 100, maybe 15. No, how many times? How many classes have you created? We'll go with 100. You guys have created 100 classes. We'll just go with 100. Okay. This table will have 3 columns. Column for customer ID, column for customer name, column for budget. Okay. There is a new file that we're going to create next that's going to basically tie the two things together. The things being the database and this class, which is called customer. Okay, so we have to have what's called a context file. Okay, we have to have a context file, and that context file again is going to kind of do the mapping of the database to the class. And so I'm going to go ahead and add a new class, and I'm going to call this customer context. Okay, so by convention, right? I'm naming this by convention. Like that's the thing that I'm working with, and the context file is ultimately what the context does is kind of like connects you to your database. So when I see the word context, I'm thinking there's my connection from my C# into my database. It's the database context, if you will. database context. I'm going to add this. I'm going to mark this as, now on this one, kind of comes in internal. I'm going to leave that as internal. And I'm going to inherit from DB context. So this is kind of new. In order for this to work, notice if I don't have this using statement, using entity framework core, you're not going to be able to inherit from DB context. That will become an unrecognized type. You had to install the package, and you have to have this using statement for Visual Studio to know what that class is. That is a class, DB context class, and this class that we're creating has to inherit from that. Okay, again, we're not going to like create this mapping very manually. All we have to do to create this mapping is create a class that inherits from this class of DB context. Okay, that's going to help us map our customers to a table. And so the next step is, what is the name of our table? And this is how we do this. We're going to create a DB set of type customer. Customer is the class that we just created. That's a generic, right? The DB set is a class. It accepts a generic type of type customer. Customers get set. Now the syntax is a little weird here, right? Something new. We haven't seen this before, but what is this doing? At the end of the day, this is creating our customers table in the database. Okay, so this name that we give it right here is the name of our table. Okay, and this is the syntax for creating that table. Okay, nothing. Now this table, customers, is a table of customer objects. This is an object database mapper. So the table name is customers, the object or the class is customers, right? DB set, linking those two things together. And we are off. Now, the next thing we need to do is basically point our application at our database software. Like, you got to point it at a database. Remember I said we're using SQL Express. Because you guys have, it's an instance called local DB. So SQL Express is the version. When you install SQL Express, you get to name your instance. So we have an instance of SQL Express running called local DB. And local DB and the MS SQL local DB. I just want to point that out right there, right? Everyone can see our instance of SQL Server called local DB MS SQL local DB. And as you know, under here we have our different databases, and inside of the databases we have tables. Okay, so we need to point our application software at the database. Okay, this is very commonly called the connection string. The connection string is connecting your application to the database. Okay, connection strings are often a pain in the neck because your connection string when you're in development, right? My connection string to my database on my local machine is going to be different than when I have a connection string on a deployment server. So when you go to deploy your apps, you always have to change your connection string. So like wiring them up locally, not so hard. Wiring them up live for production is a little bit harder. Okay, so when you actually deploy a piece of software, you always have to change the connection string. Okay, in reality, our databases nowadays are like stored on like AWS or stored on Azure Cloud, and you have to give not only what is the server where your database is hosted, but what are the credentials to authenticate to that server. Okay, so connection strings have all of that information. You had a question?
Are you able to keep a local database on the computer the app's running on?
Yeah.
Okay, so you don't have to do it if it's in cloud. You can
Yeah,
still.
yeah. Just we're in development here. I mean,
Yeah.
we're not really deploying this to a live production thing. So there's a method. There's a method called onConfiguring, and it takes in this object type. Notice I just kind of auto-filled it because it's right. But the object type is DB Context Options Builder. This options builder, how you configure your options, aka how to configure a connection string. Okay, so I'm going to remove this line of code and I'm going to say, hey, my options builder, I want to use SQL Server. I'm going to use SQL Server. And this string is likely where some of you will have typos, right? You have to be kind of precise when you're typing this, because this is a string without IntelliSense, and I will type it myself, and there's, because I'm not perfect, a chance that I have a typo. So remember I said that my server is local DB 2 backslashes MS SQL local DB. Now I pointed at that for you is just to say, hey, if you wanted to kind of come in here, rename and copy this, and just kind of paste it right here. Okay, that'll help you avoid some typos. Okay, but that's my server. I'm using local DB. Now here, database equals. Okay, this is our database name. So my database, you know, of customers, I'll just call it, how about ranking customers? Okay, so this will be the name of my database. And there's a little bit more again, so again, likelihood of typos is high. Trusted underscore connection. Okay, on some level, trusted connection, sure, we trust it. I mean, what else is there to say about that? I mean, I'm sure that has to do with, you know, where it's coming from, right? Whether you're coming from across the internet or you're coming from a local trusted connection. You know, internet probably not that trustworthy. Local trusted connection, sure, it is a trusted connection. Multiple active result sets equals true. And this kind of says, hey, we can have multiple people can work with this at the same time, and that's a whole nother ball of worms that we're not really getting into, but that's the connection string. That's what you need. And because there's a high likelihood of typos, I'm just gonna maybe copy and paste it in Visual in Discord.
Does it need to be capital or lowercase?
Does what now?
Does the word true have to be, is it capital or lowercase?
You know, I don't think the case sensitivity actually matters. It should resolve either way. Yep.
Is it okay if there's like spaces and stuff, like if you just accidentally spaced after the semicolon and started talking to me?
You know, that's a good question. I don't have spaces after mine. So it's one of those things, I just always do it the same way. I haven't always experimented with those questions. So I would avoid it because I haven't, I've always just done it the same way. Okay? So I am just out of, I'm going to take this from a prior demo. Now this is literally copy and pasting in what I just typed. And just to make sure I don't, and I'll call this ranking customers. Okay. So there's my connection string, right? So I've created a customers table. I've told my application how to connect into a database, and I've given that database a name called ranking customers. Now, the next part, because we're doing CRUD operations, the next part is not necessarily mandatory, but I'm going to do it. And I'm going to give my application some seed data. And seed data is kind of what it sounds like. It's a place to start from. And so you seed the database with this initial information. You do it one time just to put dummy data into the database, or not dummy data, but like some initial data. This will happen one time when the database is built, and then after that, you don't have to ever do it again. So my seed data is done like this: protected override void on model creating model builder. Okay, so there's really two methods that we're working with. On configuring is our connection string. On model creating is our seed data. And this is going to look like this. We're going to say model builder. That's our parameter, right? Model builder is our identifier of type model builder. So we'll say model builder entity, an entity of customer, has data. Okay. And so kind of terminate that with a semicolon. And I'm going to say new customer. And I'm going to use the object initializer to initialize these customer objects. When you're seeding data, you do have to give the ID, even though it's set to be auto-incrementing when the database is created. You do have to give so there's my 1 customer, 2 and 3. Of course, I'll increment customer ID to 2 and customer ID to 3, and I'll give it a couple random names here. Delete my comma right there. So I'm basically putting 3 customers into my database just as some initial seed data, which is the next step. Okay, and so we're now at the point we've created our entity. We've created this thing called a database context class that's going to help us tie in our classes to our database. We configured a table name called customers. We configured a connection string to our database, and we seeded that database with some seed data. Now there's 2 commands that you have to run to spin this up. Okay, and so the first one is called add migration. Now notice down here there's this package manager console. So these are command line commands that you're going to have to run. And so the first command is called add migration, not case sensitive, add migration, and you just give it a name. So this is my initial database migration. What a migration is basically creating the database or modifying the database. Anytime you work with a database, you have these things called migrations. You can modify your database with this. So I'm going to type in that command, and I'm calling my migration my initial migration. I'm just calling it the initial database creation. You could call it DB creation, whatever you want. Database creation. Call it initial. I'm going to click enter and see if I've made any mistakes. Okay, it did do a build, and it gave me this. This is meaning it's working so far. Everything's so far so good. When you do this, notice it creates this file called DB creation in this migrations folder. Okay, and what this does, this file explains you wrote C#, but what is the database table? Notice there's a create table called customers with these 3 columns. Notice the data types are integer. Notice we made a string in SQL, but a string in SQL will map to a database type of nvarchar max. Remember, there are no strings in SQL Server. There's nvarchar max and nvarchars. So the data types in C# don't match the data types in SQL Server. So this entity framework said, hey, in SQL world, you got a string, or excuse me, in C# world, you've got a string. In SQL world, we've got nvarchar max. I said double. Didn't I create my budget as a double? But in the database, well, we don't have a double. We have floats in SQL Server. So it maps data types for us, which is a beautiful thing. Really beautiful thing. It also created a primary key constraint. So there's a primary key because of that customer ID column. Okay, we insert some data. So here's our dummy data that we're seeding in. And that's when you run the migration, it'll create this. If you want to revert that migration, notice there's another method called down that it would just basically undo that. So the up method says what happens if you run the migration. The down method, what happens if you revert the migration. So how do you run the migration? Well, update database, that's our second command. So update hyphen database, you'll see that applies the migration, and then it says done. Okay, migration created, that's done. What did that do for us? Let me go in here and refresh my databases. Notice I now have a new database called rank and customers. Notice if I expand that out, there's my customers table. If I expand that out and I look at the columns, I've got 3 columns. I see this little key here for the primary key for the customer ID, customer name, and budget. And if I view the data, I can see my seed data has been seeded into my database tables. Right? Wonderful. We have created our table in a database of customers using entity framework and this thing called a DB context class, and we are well on our way to performing CRUD operations. Okay, so let's go ahead and pause here for a minute. It was brought to my attention that some people might not have the package manager console window. So down here where I was running these command line commands, if you don't have this window here, you will find that right next door to the manage NuGet packages. We already clicked this button. Right above it is the package manager console. So you click on that, that'll bring up this command prompt that I was typing in the commands. Okay, so we have got a start using entity framework, and now we're going to get into actually doing the CRUD operations using a SQL-like language, LINQ, it's integrated into C# and it's got some IntelliSense. And so again, create, read, update, and delete. The first one being a read option. So reading is the most complex one because that's your search. And search logic can be very complex. Or, I can make it real simple by saying, hey, just give me all of your customers. And that is a read operation. But you could also say, give me your customers where this and that condition and the other condition. And as you know, there's a million ways to read customers. Give me all of your songs where artist name is this. Or give me all of your products that look like that. There's a million ways to read data. And we'll kind of start there. We're not going to hit all the ways to read data, but we'll get a start. And we kind of left off. We looked at the data. We created the migration. We've got our file. Back to the form. Let's get it all the way back to the form and view the code. Now, to get a start, remember the context file that we created was called customer context, and that was the file that linked us to our data. And so we need to create an object using that customer customer context. So I'll say customer context called customer data. And then when the form is initialized, now this is the form constructor. So basically when the form boots up, we're going to say customer data equals new customer context. Okay, so we'll initialize our object, right? We declare our object here, we initialize it here. We do that so that this variable is in scope throughout the whole form class. And so we can have access to our customer data in any method, not just inside of the constructor or what have you. Now, very commonly, I mentioned this before, when you're pulling data out of a database, you'll store it in a list. And so I'm going to create a list of customer called customer list, and just initialize it here. Now, if I want to access my customer list, again, I can kind of change the scope to something like this, and then initialize it here. Okay, and that's fine. Let's go ahead and create our list of customers. Actually, instead of initializing it as an empty list, let's go ahead and just read all of our customers from the database using LINQ. Now, LINQ is a little different, right? You just wrote SQL. And so the first thing I'll teach you about LINQ is in SQL, it's select from where? Order by, right? In that order, you're selecting these columns from this table where these conditions exist, order by last name. Those are the keywords, and those are the order of the keywords. Of course, LINQ is just here to be different. It's from where select. I believe order by goes in here. I'll tinker with this. I might be wrong about the order by. But the keywords are just different. You're going to say from where select. And let me check my notes on the order by. Actually, order by might even be from order by. Okay, point is, the order of your keywords are just different in LINQ. And so here we're going to start with our customer data. So our customer list, we're going to start with customer data dot customers table. So really this variable represents our database. So maybe I should rename it customer DB. I think that's a good name. So let's say customer DB. You know that this represents the database. So when I say customer DB dot customers, okay, that's the customers table. And so I'm just going to kind of start with a select star. I'm just going to say from where select. I don't want a where clause. I'll even simplify it more. I just want all my customers. Dot select. I'm not even going to put in a where clause here. This is a method. So the select C represents our customer. So this is a identifier. This basically reads like select the customer and select the whole customer. Like I could select from the customer, select the C dot customer name. Whoop. So you can see that C represents the entity customer, and then you can pull out a customer name. I don't want to do that. I want the whole customer. Okay, so this is the equivalent of a select star in LINQ. So notice we didn't even really say from. From comes from customers. Customers, we don't have a where clause. So this is just kind of like a from clause and a select. Right? From the customers to table, select the customer. And every customer, now convert it to a list. We've got a list on the left, we've got a list on the right. I'm going to for each customer in customer list. So this is pulling the data out using LINQ. This is a select star. This is kind of like the simplest LINQ query that I can write. This is selecting all of the customers and putting them in a list. A C# list on the left, a list on the right. We loop through our customer list, and I can kind of go back into my customer table, and I'll make a toString public override toString. Whoop. And I'll kind of do this. Customer name has a balance of a budget of budget :C. Okay, so when we print out a customer toString, it'll just say the name has a budget of budget. And for each here, let's just complete this exercise by putting in a result label. And you can, once you have the data out, you can format it how you will. Here's a label. I'm just going to identify this label with the name of label result. In my toString, I'm going to put in a line break as well. So each customer will put in a line break. Text is empty. So when the form loads, I'm going to say label result plus equals customer toString. Label result dot text, and spin it up.
I think it throws an error. Oh, I see.
This makes me happier than it should. This makes me very happy. Because for the first time, we're persisting data in a database, bringing it into our application, and making this more real world. Right? So I hope you guys, see the value in this. I think it's pretty cool. This is the toString. It has the customer name, has a budget of some dollar amount. That's when the form loads. And so we can kind of throw that label off in the corner because we're going to be doing more things. Okay, now the next thing, that's one way of reading data, but you might want to filter your data, right? So you could filter by customer ID, you could filter by budget amount. Let's filter by budget amount. I only want to see rich customers, right? Big budgets, right? So let's ask the user to enter a minimum budget into a text box and a label, text box and a label. Text min budget. And a button that says button search customers, and text is search. And let's add a label here. this label customers, label min budget customers, min budget custs. Okay. Search. Okay, now we've got a button search. Let's get our data into a variable, probably a float, min budget search equals float dot try parse. No, we're not going to go. We're going to go float dot parse text min budget dot text. So we're going to read out of the text box, parse it into a float, store it in a float called min budget search. Now we're going to use that in our LINQ query. Here we'll update our customer list equal to customer DB dot customers. So from is the customers table dot where c dot where my where clause. Hold on. If you don't do this every day, you forget the syntax. Instead of an equal, it's an arrow where the customer c dot budget is greater than min budget search. Select the whole customer to list. Again, the order is different. Now we're providing a condition. We're filtering our customers by their budget where the budget is greater than, so where the customer budget is greater than the number that they put in. Remember, my budget's for like 10, 20, and 30. And so now let's for each over our customer list again. And in our label min budget cust, print out the customer's toString there. So we're going to boot this up. And we've got our 3 customers reading them all. But if I say 15, 1, 2, 3, you can see now we're filtering only where the customers have a budget more than $15,000. Let's loop in the order by because again, notice I'm just doing customers order by the customer name. So now we got A, so basically, you know, the first name, it's going to be alphabetical order. So if I say $0, notice it rearranges in alphabetical order. A comes before C, comes before E. So our sorting is our order by can be placed in there. It's worth noting if you go online and you're looking at LINQ examples, the first thing you need to recognize is that there's really 2 ways to write LINQ. I'm using the more modern approach, which is the dot notation. So I'm using customers dot order by dot where, and these are all look like methods that you're used to, and you can format this to look a lot prettier. Right? giving you guys this little bit of code makes you very powerful in what you can do, right? Not only can you hit all database records, but now you can hit database records where certain filters exist. You can sort and order by conditions and select. Now, again, you could, if you just want to select like pieces here, you could select customer name, but that's not then going to be a list. I'm selecting the whole customer object and then printing it all out. What I was getting at is there's another LINQ syntax that uses words. And so it looks a little bit more like this. Okay, and I'll just put in a little just a little one-off here, because you guys are probably going to have to look at some different syntaxes for LINQ, because I'm not giving you the whole toolkit here. You might find examples that use keywords like from, where, select, instead of this method syntax, which is kind of the more modern syntax for writing LINQ queries. So I would avoid the keyword syntax versus the dot notation syntax. If you want to look for an individual record, right? So this is returning many records. Let's do a similar thing, but let's look for like a customer by ID. So I will just say enter a customer ID and do a little button click for button ID search. Okay, now we're not looking for a list of records, we're looking for a single record. It's really not that hard. You just change the last kind of method. Instead of converting it to a list, you convert it to a single customer. So we'll do customer cust equals customer db dot customers. Okay, before I write this query, let's get our ID. Int cust ID equals text. Oop, I didn't name it, did I? Text cust ID. Int dot parse text cust ID dot text. So we're reading into the customer ID. And there's your method that you're looking for, first or default. Or, because first or default, it literally, in the event that you had multiple customers with the same customer ID, it would just return the first one. That shouldn't be the case. But since you know that there is, that's one way of writing that query. Now it's going to give you a little here, is that you can suppress that with an exclamation point. And so that's basically this error says that, hey, this query might return null. And because it might return null, you might want to make this a nullable type. And so by putting that question mark there, you're now making customer nullable. And so then customer can store nulls. And then you can say if customer is not null, let's just put that in cust2string. So if customer is not null, then print out that customer's information. Okay, so a couple ways of solving that green squiggly problem. Make it nullable or suppress the warning. And let's run that. I didn't make a separate label, but you get the idea. If I search for customer ID of 1, I just got to move my label so that it's let me move my label. Label min budget cost is kind of hiding right over here. Okay. So customer ID of 1, 2, 3. Minimum budget of 10,000. I didn't clear my labels, but you know how to do that. Label, put it in different labels. Label min budget.text is empty. Clear it out both times. So that's how to provide search. That's the basics of LINQ. Literally a tutorial on W3 Schools can teach you. Now that you know SQL, you can get help with LINQ. Now, again, benefit is that you get this kind of compile time. Like if I say budget 1, 2, 3, like that's not going to compile, right? If you were writing pure SQL, it would be written in the form of strings, and those strings don't give you compile time errors. And so that's one nice advantage of writing LINQ is you get compile time versus runtime errors. Okay, rolling along, we'll go ahead and kind of put our label over there. Let's create a new customer. And so we need a name and we need a budget. And we do not need an ID. The ID, keep in mind, will be auto-incremented from the database. So let's just kind of bring in a couple more text boxes. Oh, don't crash on me. Copy, paste, haha. So here's a toolbox, label, customer name, copy, paste, customer ID. Customer budget, not just budget. So these are the inputs. Come on now. Get the right properties. Customer budget. Okay, we'll call this text add, txt add name, txt add budget. Just kind of get the feel for what operation we're doing. And button button add customer. Great. There's a method. You might guess the method is called add. You would be correct. And so to our DB context customers, we're going to add a new customer. So let's spin up our customer object. Customer, new customer, bless you, equals here, I don't like adding that. I'll say customer add customer equals new customer. And I'll say budget equals decimal.parse text add budget.text. It's double parse. Customer and customer name equals text add name dot text. So basically, by the way, kind of a fun little syntax here, because it can be assumed that there's a newer syntax where you can leave. There's a newer syntax, I'm forgetting it, what it is, to leave maybe the keyword customer off. Here, let's see, it's going to tell me right here. New expression can be simplified. Oh, it's new parentheses. It's going to assume customer. So you don't need the keyword customer on the right. So this is a newer syntax for creating customer objects. I think that's interesting, new syntax. Let's do the add. So we have our context called customer list or customer DB. Customer DB dot customers table dot add customer. Syntax not crazy, pretty simple. Here's our customer DB, customers table, add customer. Of course, you can do a nice little try catch around this. Handle DB errors however you wish. Now there is also something that's not mandatory, but I'm going to suggest it here. Customer DB.save changes. So you, suffice to say, in some environments you have to call save changes. This is not one of those environments, but it does kind of put in some good coding practices, I think. You want to call save changes. So here, spin up a customer, add that customer to the add method, save changes, and let's add a customer. Now, of course, we should here's a little logic. Check this out. Everyone kind of zone in on this for me. It's a simple for each loop, you know, looping through all of our customers. Notice my customer list is what we're looping through. So I'm going to make a method. You can right click this, and there is a way to extract this into a method. And quick actions and refactoring, extract method. So I'm going to call this show customers. Oops. Let me try this one more time. Highlight this. Right click, refactorings, extract a method, show customers, and then enter. Now I'm going to list of customer called cust list. We're going to loop through cust list and then pass customer list. So basically, you know, take your logic and extract it into a method. It went ahead and did that. Now I've got a method called show customer, so I don't have to now I actually don't have a list of customers here, so maybe I don't need this list. So customer list is actually global in scope, so I don't need a passive. So let me refactor this. Show list, show customers. customer list, it'll just loop through. So now I could just call show customers. It'll loop through customer list. Customer list is kind of more global in scope, so I don't need to do that. Let's see, show customers loops through. Now I can just call that method again. Show customers, there we go, refactored that, and okay, so my code is still working, right? We're looping through all of my customers. But now the idea is I'm gonna add customer, I'm gonna save changes, and then I'm gonna show customers, and that should show my new customer. And I just wanna make sure on show customers, I'm gonna label results.text is kind of cleared out at first. So if I add Jacob 1, because we got 3 Jacobs, and he's got a budget of 40, 1, 2, 3, and I click on add, not exactly working how I wanted to. Of course, you want a success message saying customer added. Let's take a look in the database and see if our Jacob was added. In fact, if I just run it again. Okay, you can see Jacob 1 was added to my database. My label just didn't reflect that. Okay, so Jacob 1 was added, and in fact, if I go into my table, if I go into my view data, you can see Jacob 1 was added. So it's working, it's just my show customers here's what I need to do. Show customers, I'm going to run this query. I'm going to update my link, right? I need to update my link customer list to select the new customer list, right? So I need to rerun my query to get the new customers, right? Because there's a new list. So that makes perfect sense. So Jacob 1, let's add in Jacob 2. And Jacob 2 has a budget of 50, 1, 2, 3. And I should click add, and Jacob 2 is now in there. And if I enter a minimum budget of 40, 1, 2, 3, it's greater than 40. It's not greater than or equal to. So there's only one Jacob with a budget greater than 40. Very cool stuff. Of course, that leaves 2 more operations. Thankfully, we have these methods, such as the add method, that make this not too hard. Let's make a drop-down list of customers, right? So we can delete a customer that's in our database. And so here's our combo box. This will be just a list of IDs. CBO cust ID, IDS. We're looping through and show customers. We're looping through each customer and customer lists. CBO items. Let's clear our items. So on show customers, we're going to clear our items. And CBO okay, so here we could see our 5 customer IDs added to our list. Yes.
Found that if you don't put the add in a try catch, it won't work at all. It'll won't throw an error, but it'll not add.
it's good practice. Anytime you're making database calls like this, try catches are your friend. I mean, this is one scenario that to my understanding you're really going to be using try catches a lot with databases. And the exceptions you might catch might be more specific exceptions as you hit them. So anyways, let's see if I add another customer, because right now we've got 5. Let's add Jacob 3 and a budget of 60. We click add. Jacob 3 gets populated there, and his ID gets populated in the drop-down list. So now we need a delete. So we'll go toolbox, label. To kind of state maybe something that's not so obvious but will become obvious with time, deleting is super risky, right? It's the most risky thing you could do is delete data. So it's more advisable to like disable a customer account versus delete a customer account, right? So have an enabled property, and enabled as false is way more safe than deleting a customer, right? In the real world, you don't delete customers, you just disable them. And so, again, maybe not so common sense, but that's what you do. You disable your customers, you don't delete them. But we're doing CRUD, we are deleting for practice. Let's do that. I need a button click event, or maybe I don't want to delete there. I'm gonna delete on the button click.
So I'm guessing like being able to implement this into the code is basically kind of like the final test for.
Yeah, I mean, this is a really good template for your final project, doing CRUD on a database. I mean, that's what I'm doing here. You're just gonna have to make it work for you. Okay, so delete customer. Int cust to delete equals CBO cust IDs dot selected value. Now we'll cast that into an int and see if that makes it happy. And I'm just going to make a little like label here to test that just want to make sure I'm reading this ID right, because I don't work with this every day, and I just want to make sure. Label delete, LBL delete, LBL delete dot text is cust to delete to string. Okay, so I just wanted to print out the number in the label right now. And so if I say 1, yeah, I didn't think so. I'm gonna do selected item, see if that. There it goes. Okay, selected item. All right, so we got the ID. Selected value. There was no value configured when I put the data in, so it's coming back null. That property was never configured with the data going in, but the item was configured. So we've got our ID. So we're gonna run a remove method. So let's first select the customer. So we have to select the customer. We know how to do that. Customer cust to delete equals DB, what's our database? Customer DB. So we're going to select the customer first. Customers. There's also a find. This is another way of looking up by ID. Cust ID to delete. You could also, instead of running a query like we ran before, you could just call the find. And that should return the customer by its primary key. The primary key in this case is the ID. So you pass the ID, make it nullable. And again, if customer is not null, try catch. Customer DB, customers table, dot remove, cust to delete, and save changes. And then I'll give a little label, customer deleted. Catch exception EX. Handle your errors. Handle your business. Breakpoints are your friend. I'm going to hit this breakpoint and step through it just to watch it execute. So Jacob number 3's got too much money. We're going to delete him. And I'm going to click on step over, step over. So customer to delete. You can see that once line 91 is executed, Jacob 3 has a customer ID of 6. So it did select my customer properly. My customer is not null. So it's going into my try catch. Save changes, customer deleted. I click on continue. And it does say customer deleted. Of course, I need to update my show customers. So what I'll do is I'll call show customers here. But now notice when I reload this up, Jacob number 3 has been deleted. And so if I delete customer ID of 5, Jacob 2 is deleted. Customer deleted, customer gone. So we've done create, we've done read, we've done delete. How about update? Last one but not least, we'll get through this and the demo will be over. The pain will be over for today, but it will continue for tomorrow. And the next day. And the next day until class is over. Okay, so we already have the IDs and all that, so let's just, I guess, update by ID. Copy paste. We'll say update customer by ID. Now this will be CBO update by ID. And if I kind of view the code, CBO update by ID, items add, okay. So boot that up, test it. We've got our IDs of customers to update. Now when we selected index changed on our combo box, we're going to populate some controls with customer information. All right, so where we left off, we took a quick breather. I gotta remind myself where we left off because, okay, so we got some IDs here. We have an event so that when you select one of these IDs, we're just gonna read that into an int, and this int needs to be class scoped. So I'm gonna mark it private int cust ID, cust update ID, something like that. And then here, cust update ID equals, and like we did up here, we're going to use the selected item, not selected index, selected item. We're going to get it an int on the left and an int on the right, and just do a little label update right here. And text is empty. Label update cust. And so here, label update cust dot text equals cust to update. So I want to make sure that we can select it, and then it updates the label. Again, take little baby steps here. 2, 1, 3. Good. Okay, so we're selecting, we get the ID, then we have to read the customer out of the database, and then we have to update that customer, and then we have to save changes. So we have this variable here. I really don't need to do this. All I need to do is update the variable when they select the index. And let's put a button, copy and paste a button when Visual Studio catches up. Let's put a button here to update the customer. Okay, now on this, all right, we're going to do a little bit more. Let's go ahead and find the customer by ID. Customer update cust equals customer DB, customers find underscore cust update ID, and make that nullable so that goes away. And if update cust is not null, let's populate some controls with budget and so I'm just going to copy 2 text boxes, paste them, and a couple of labels and paste them. Okay, and this is a little sloppy. So this is going to be customer name, and this will be customer budget. And so when they select an ID, we're going to change, we're going to update the customer, read the customer from the database. If it's not null, then let's name these text box, text update name, text update budget, text update name dot text equals update cust dot customer name. So we're doing read operations, right? We're reading the customer name and putting that into the text box. Text update budget. I am not going to put this in a I'm not going to convert it to currency, right? I don't want that $sign, because then when I go to update the customer, then I got to take the $sign out, right? So I'm just going to take that budget to a string and just convert that to a string. So now if this is working, when I change this, it's populating those text boxes with my customer information. Then I'm going to click on Update Customer and do the update operation. So that's going to allow the customer to say, oh, modify it and click on Update Customer, and that should save it in the database. Okay, so when I click on any one of these, it's updating the fields. Now I just kind of finish that out. So this is all happening on index change. When I click on the Update Customer button, oops, undo that change. We don't want that. Let's call this button update. Okay, let's go ahead and read our customer again here. It might, instead of hitting the database twice, here's what I'll do. I'll change the scope of my customer. I'll make my customer scope here. And then back down here. Okay, so now I have access to my customer in this other method. I'm going to update my customer. Update cust.customer name equals text update name.text. Update cust.budget equals text update budget.text. Now this is, the user is going to modify what's in those text boxes. They're going to click the update button, and we're going to update the properties of our customer name and of our budget. This is a double on the left, so we have to get it into a double on the right. So we'll say double.parse. So we update our customer object. We then call the update method. So that exists on the, I always forget the name of my thing here. Customer DB. And this is probably one of those nullable things. Update cust may be null here. So you could check for not null. If update cust not equal to null, customer DB customers update cust customer DB dot save changes. Put this inside of a try catch. Handle your business. Handle your exceptions. And here, if that works, I'll say label update cust dot text is update cust dot customer name has been updated. And because we wrote a method to display everything, I'll call show customers. And again, I like breakpoints to troubleshoot the first time you're running it, just to see what's going on. And so when I do this, customer Evan, customer Charles, customer Ashley, customer Jacob, I'm going to put my middle name in here. Anyone know it? Of course you don't. Evan Andreas Gudmestead. True story.
Guess that one.
True story. All right, let's click on update. Update cust. It does have me as the customer, so it is not null. So we should go inside. And the customer name is currently Evan Gudmestead, is being updated to Evan Andreas Gudmestead. So we're updating the name. The budget remains unchanged. So 10K before, 10K after. We try and update the customers. It worked. We save the changes. We say the customer has been updated, and I click play. And now you could see the label says Evan Andreas Gudmestead has a budget of $10,000. And if I check my table to view the data, did it actually change? You could see Evan Andreas Gudmestead has been updated.
That was a question that came up. I didn't ask it, but it was like, when before we used to do databases, once you're done with your form, it's like
It's
it'll,
gone.
like, revert. Yeah.
Yeah.
So,
Now it's permanent. If I run this again, the data persists. It is still Evan Andreas Gudmestead. I can close it or reopen it 1,000 times, but it's reading from a data base. The data is persisting, and we just ran through this quick demo of Crud on a customer with our applications. I'm going to stop the demo here. Pretty cool stuff, if you ask me. Hopefully, you guys feel a little bit of that.